Question number 37. The Fourier transform of a Gaussian time pulse is dash. Options: uniform, a pair of impulse, Gaussian, Rayleigh function. So this question is again quite simple. We can answer in 30 seconds if you know the concepts of Gaussian pulse Fourier transform. So just let me recollect few concepts. So these are the two functions in signals and systems where its Fourier transform will be same. So first one is Gaussian pulse, second one is impulse signal. Gaussian signal and impulse signal are the two signals which will have the Fourier transform as same pulse. Maybe there is a change in the amplitude and there may be delay in the signal, but the nature of the signal will not change. The nature, see, it doesn't mean that they have same values exactly as it is, same shape and same shape they'll have, same values they may not have. What I'm saying is the nature of the pulse will remain same. The nature of the pulse will remain intact. They'll not change. So when you choose a signal as Gaussian signal, the Fourier transform will be Gaussian once again, but there may be change in the amplitude and there may be the delay or advancement in the signal. And similarly, when you choose a signal as impulse, the same signal you will get as an impulse, Fourier transform, but there may be change in the amplitude as well as there may be change in the time delay or time advancement of the signal may takes place. So let us see. So the right choice is, you can easily answer now, the answer is Gaussian once again, because the Gaussian time pulse will have the Gaussian itself. I already told just now. Let us so this question is very simple. You can answer within 10 seconds, maximum 10 seconds if you know previously these concepts, and try to remember the impulse also. Okay, you may get this time. Now let us see the extension. Extension is also very important, because I am seeing this extension in many exams, many exams, and repetitively. So try to memorize. So I am requesting everyone, try to memorize. I am seeing this question many times. I am stressing this. Okay, fine. So let us see the extension. So let me consider a Gaussian function or signal. So this is a Gaussian function. The area under this will be 1. You might have already known. Area under Gaussian function will be 1 always. If there is some amplitude, see, this is a Gaussian function whose amplitude I am taken as k. K is the amplitude at origin. When time is 0, the amplitude I have chosen it as k. So the area of this pulse will be k. Whatever the amplitude will be there, that it will be the area of this Gaussian pulse. Fine. Now, when you choose this signal and somebody wants to know its Fourier transform, so somebody asks you what is a Fourier transform, then the Fourier transform will be, once again, it will be Gaussian. Okay, one second. Yeah, so it will be Gaussian. Yeah, same shape you will get. So but there may be change in the amplitude. It may not be k now, it may be some new amplitude, we don't know. Okay, we need to find that. So the time it will be x of f, because frequency axis, right? So this will change to f. Now what is its f of I have given that mathematically x of t is nothing but, Gaussian function is nothing but k into e power minus at square. So please try to remember this expression, mathematical expression, k into e power minus at square. Whenever you do the Fourier transform for this Gaussian pulse, if you try to do manually, it will take a lot of time and you need to use some kind of special functions. So it is a tedious job. So I don't advise to do all this in the exam hall when you get hardly 1 minute. So when k into e power minus at square means, whenever a Gaussian pulse is given and somebody asks you its Fourier transform, just try to remember this formula. Very simple. I'll tell you how can you memorize. So k is there, you write k as it is. Just you need to add this extra factor, root pi by a, root of pi by a. This is the extra factor you need to add. Then e power minus at square. This will be similar to e power minus at square, but this is a frequency domain. Instead of t square, write f square. So you are done with this term. So only extra term, instead of a, you need to write pi minus same, minus same, pi square by a. So everything is same except these two terms, root pi by a and here pi square by a instead of a. So try to memorize this. Very important. I'm stressing this once again. See, because many times asked in GATE, IES and ISRO. Even ISRO papers has this direct question. He'll give a signal something like this. I'll give you a question. This is an example which I have chosen from previous papers. So e power minus 3t square is the question given. Then he is asking what is the Fourier transform of it. So simple, just compare with the standard formula which I gave, k into e power minus 8t square. K is 1, right? So 1 into e power minus 3t square. So k as it is, right, 1 root pi by a. I told root pi by 3 because a is same as 3. You can compare, very simple question, into e power minus pi square by a is again 3 f square. This is the answer. You can find this in the options, you can directly answer. Very simple. Okay, so try to memorize, and sometimes the question will be like what is x of 0, means you will find the Fourier transform of this, right? So he will be asking like this. First question is like what is this Fourier transform, then your answer will be root of pi by 3 e power minus pi square by 3 into f square. So somebody will ask, can you plot this? Yes, you will plot something like this. Okay, so what is its value at x of 0 at f is equal to 0? Then it's again simple, it's nothing but just put f0. What you are going to get? Root pi over 3. So this is the one type of other question. I mean, just he'll be asking what is its value at f equal to 0, f equal to 1, whatever he likes in gate generally. So it's a simple question. Try to memorize this formula. So I'm stressing once again, please remember this formula. This is very important. These two are Fourier transform pairs to each other. Please remember this. K e power minus 80 square. This is k into root of pi by a e power minus pi square by a into f square. Okay, thank you.